Okay, so let's talk more about the mole. Always fun. So what's really significant about the mole is that it is the number of atoms of a given element or substance, any substance, required to give a mass in grams equal to the mass given on the periodic table, which is we typically think of in AMUs. So since on the periodic table it says that one single oxygen atom weighs 15.9994 AMU, you might see it as 16.00 if it's rounded off, then 1 mole of oxygen atoms weighs that many grams, 15.9994 grams. Lithium has a mass of, a single lithium atom on average has a mass of 6.941 AMU, so a mole of them has a 6.941 grams as mass. So remember that those individual atoms actually don't necessarily have that exact mass because they are an average. That number is an average. But when we have a mole of them, we have so many that it just washes out to an average. The same is true for formula molecular weights. So water has a mass of 18.0152 AMU, so a mole of water has a mass of 18.0152 grams. So that's pretty straightforward. Now, this gives us, so remember I showed you that we already had a conversion, sort of a map. So moles of A, and I can use Avogadro's number to go to particles of A. Now I can use this value, this numerical value, to go to the mass of A. I'll show you how to do that. So, we call, by the way, this average, when it's in AMUs, we call up the atomic mass or the formula mass. When we're talking about it in terms of grams per mole, we call it molar mass. So the molar mass is always going to be numerically equal to its atomic or its formula weight. So the molar mass of some common substance are this. So hydrogen, 1.0079 grams per mole. Instead of AMU, which it's also important to understand that when we write it as 1.0079 AMU, that's AMU per one atom. And then hydrogen is 1.0079 grams per mole. Carbon dioxide is 44.01 grams per mole. And I got that by just adding up the masses of carbon, the 12 point, I took 12, because carbon dioxide is CO2. So I just took 12.01 plus 16 plus 16, and I got 44.01 grams per mole. All right, so we just add up the formula masses that way, as we did before. Now I can determine the mass of a certain number of molecules, or I can determine how many moles. So here we go. So I have 23.3 grams of CH4. And now what I want to do is I want to find CH4 molecules. Right? So what I'm going to do is I'm going to convert. So I have to put grams of CH4 in the bottom. And I cannot go directly from grams to molecules. So don't get to thinking that it's 6.02 times 10 to the 23rd molecules per gram. It's per mole. So before I can get to molecules, I have to go from grams to moles, CH4. Well, how do I know what the relation is between grams and moles? Well, that's when I look up the molar mass. So I have to add up the mass of carbon plus 4 times the mass of hydrogen. So I take 1.01 times 4 plus 12.01, and I get 16.05 grams per mole. So this is the conversion factor I'm using, 16.05 grams per mole. And now I can do the second step. I've got it in moles. I can put moles CH4 here, and I can put CH4 molecules here. And remember, in 1 mole CH4, there are 6.022 times 10 to the 23rd CH4 molecules. So now, taking that number, so I take 23.3 divided by 16.05 times 6.022 times 10 to the 23rd. And I get 8.75 times 10 to the 23rd. So So there we go. And so now I'm going to go on and we'll do a little more practice here. So I want you to try this. Try these 3 problems, and then I will do them. So practice and try them. Okay, so determine the mass of 1.25 moles of silicon. So moles of silicon, we can go directly from moles to grams, right? Moles of silicon has to go on the bottom, and I can go directly to grams of silicon by knowing the molar mass of silicon. And so it looks like the molar mass of silicon is, where is it? 28.09. So 28.09 grams of silicon per 1 mole of silicon. And then all I have to do is just take 1.25 times 28.09 and get 35. We need 3 significant figures, 0.1 grams of silicon. Right? Okay, next one. 52.99 grams of CF4. Right? I'm going to put grams CF4 in the bottom, moles CF4 on top, 1, and I got to calculate the molar mass of CF4. Looks like fluorine is 19, so I take 19 times 4 plus 12.01, and I get 88.01. 52.99 divided by 88.01 is 0.60, looks like 21 moles of CF4. So 1 mole argon down here. So I need to go from grams to number of argon atoms. So I just sort of jumped the gun on that, didn't I? I just sort of went on autopilot. So I've got 20.5 grams of argon. I need to put grams of argon in the bottom and moles of argon up here. I have to go to moles first. I can never go directly from grams to particles or particles directly to grams. I always have to go through moles first. So moles is really going to be your linchpin for everything. You always want to go to moles. So I'm going to go 1 mole, and I have to look up the molar mass of argon. And it looks like the molar mass of argon is 39.95. And so now I've got moles of argon. All I have to do is do moles, argon, and then argon atoms. 6.022 times 10 to the 23rd and 1. And I get 20.5 divided by 39.95 times 6.022 times 10 to the 23rd equals 3.09 times 10 to the 23rd argon atoms. And there you go.